Hi, my name is Christina. I come from Quiske. Today I will show you how to use our web portal. That's where you can analyze the sessions that you have recorded with the RowP application. I will just share my desktop with you and then we can start. One more thing before going to the web portal. To have something to analyze in the web portal, you do need to upload sessions from your RowP app. To do so, you need Wi-Fi on your phone. Then you go to the Sessions tab and choose some sessions to upload. And in a moment, they will synchronize to the cloud and you will be able to access them via the web portal. This is what the web portal dashboard looks like right after you have logged in. I'm now logged in as myself, and you get a summary of how many sessions you have and what's the duration and length. You do need a subscription to upload data to the web portal. With a rower subscription, you get to analyze and store your own data. With a coach subscription, you can analyze and compare the different rowers in your crew. To access all the sessions, I have 121 here. You just click on the Sessions tab on the left, and then you get the full list of sessions. You can search them by names or by tags. You can also search them by date, and then you can scroll through the sessions simply like this. So let me show you here what the session name contains. There's the name, which you can adjust yourself. Then there's the date field, there's the boat type, even the indoor rowing machine here is represented. You can use that as well with our sensors. Then you have the distance recorded, the speed, the recording duration, and then the location of where the sensor was placed during the recording. Of course, you can also use it without a sensor, and the name of the sensor. So let's go have a look at some recent rowing that I've been doing. Let's just take the first one here. You can access the session simply by clicking anywhere on the line, and then you get to a summary field first here. This shows that the recording was 1 kilometer, 4 minutes. We recorded 114 strokes, the pace, the boat type, a quad, the speed, the date, where was the sensor placed, what was the name of the sensor, and what phone was used for the recording. The name of the session is easy to change simply by clicking on the pen here. Let's type something, and these session names are also fully searchable. So if I put here quad training for Valkeakoski, 1K drill, you can fully decide yourself what it should be called. Then when you scroll down, you get a graph, first a summary graph showing the stroke rate and the boat speed. And each ball represents one stroke. Of course, this was now quite a short recording, but if you have a longer one and if you have a need to drill in, to zoom into some time period, you can use the side bars here on the bottom to zoom in. And if you scroll down, there's really nothing more here except for the map showing where the rowing was done. In this case, was in Helsinki. You can also add tags here. But now the question is, of course, how do you access the data that we analyzed with the sensor? There was a sensor used here. It was on the left oar. So that's done by painting the strokes that you want to analyze. So you can paint everything, or then you can choose just a specific region. So here I chose roughly 20 strokes or so, and now when I scroll down, there's data here. The first graph shows the boat acceleration and speed graph of the boat. Actually, this graph does not use the sensor, it uses just the phone accelerometer and GPS to generate this data, and you can use our software to get this graph without buying a sensor. You can toggle boat speed and acceleration on and off if we want to look just at boat acceleration. You see, this is now one cycle. So in our software, we define the cycle to start at the boat acceleration minimum here. That's at the start of the drive phase. So this is the drive phase where we increase the boat acceleration from negative to positive. And then here is the recovery phase where the acceleration is close to zero. And then at a catch, the boat acceleration decreases again. This boat acceleration graph reflects rowing technique, and also the boat type influences this very much. So it's a very interesting graph to have a look at. Then when we scroll down comes more interesting things. So now these next graphs are showing rowing technique of the individual rower, in this case of me. It's measuring the performance from the sensor on my left oar with the sensor. So this is not measured from the phone in the boat, but from the sensor, and combining the data from the sensor with the phone acceleration data, and then we get a graph like this. This performance graph shows the angular velocity of the oar during one cycle. The cycle starts when the boat acceleration is 0. That's why here you can see that my oar already has some angular velocity. It's not at 0 when the boat acceleration is 0. You can see that catch is where the blade changes direction from recovery to drive. That happens before the boat acceleration minimum. It happens around here. So when my oar changes direction, the boat acceleration continues decreasing. And then at boat acceleration minimum, my oar is already moving at 44 degrees per second. And then here, where there is a kink in the performance graph, that is the angular velocity, the increase of it changes suddenly. That's where the real catch of the oar blade in the water happens. That's roughly here. So anyway, the oar performance graph shows the oar angular velocity, and the drive phase is where the oar angular velocity is positive, and during recovery the oar is moving in the different direction, that is the oar angular velocity is negative. This graph is very interesting, and especially when you plot this graph for different people on top of each other in the same crew, then you can learn about differences. For example, at finish, the slope of the curve should be the same for rowers in the same crew. So this shows how fast you are throwing your hands away at finish, or whether you are doing it in a very calm fashion. Also here in the recovery graph, you can see whether you're speeding up towards the catch or not. So you can learn a lot from this graph. Then there's also another graph that you get from the oar sensor. It's the blade flight path. This shows how the oar is moving sideways and vertically. Because we don't calibrate the sensor when we put on the oar, and here it was at a slight tilt on the oar collar, you don't need to look at the absolute angles and the absolute tilt here, but what's interesting is the shape. So it's interesting to learn how narrow this is. So for example, here my vertical angle is going from about -10 to about +4, so it's a 14-degree vertical blade flight path, and of course this should be as narrow as possible as long as you fully immerse the blade during the drive. So the drive is down here, and then recovery happens flat on the water. And you can see the full drive length as well as the full angle being about 94 degrees in this case. And these graphs are also interesting to plot on top of each other for different rowers to see differences in technique. But for that you need the coach subscription, and I will take that in a later film. And then you get the summary data showing this, the number of strokes sampled, the average stroke rate, average speed, and then this average stroke length in degrees, which is an interesting number. We can save this analysis as any name you want, so you remember it if you want to compare it with someone else. So then you need to name it so you remember it, and then click on Save Analysis, and then that will appear under the analysis here. I could show you actually one more thing, and that is if you want to see how consistently someone is rowing, then you can swap from showing average curves to showing actual curves. So the average curve shows just the calculated average curve within the selected region. When you choose actual curves, you are going to plot all the curves within that region. And sometimes it takes a little bit of time, like it did now. But you can do this if you choose just a small region. And as you can see here, the boat acceleration graph, it's pretty smooth, meaning that there's not that much differences, meaning that there were some waves and there was a bit of wind when we did this, but still it's pretty consistent. Also, the performance graph seems to be quite consistent. There's some differences in timing. There's one stroke where my catch happens actually after the boat acceleration minimum, meaning I was most likely a little bit later than everyone else. The blade flight path also pretty consistent. But let me go back to the main sessions. I'd like to show you also a sample of when the sensor is on the seat, because that's just interesting to it's a different type of graph. So here's a session where the sensor was on the seat. You can see it here, a very short session, just 23 strokes, 200 meters. And the stroke and both speed graph look interesting. It means there was a very short rowing here, and then it paused. Maybe I changed direction, and then again rowing. If you look at the map, indeed you can see that this happened in the US, a very short distance back and forth. So here let's choose to look at just a few strokes here, where the stroke rate was between 22 and 26, and the boat speed was 3.4. Then I get this boat acceleration. This is now in a single. The boat acceleration graph looks like this, and the seat speed graph is what you get when the sensor is on the seat. So now we're not measuring the oar but the seat. And you get to see positive and negative seat speed. So this is the drive, where the speed is positive. Then at backstop, the seat speed is roughly 0. And then at recovery, it's negative. And here again, you can see that my seat starts moving in the driving direction before the boat acceleration minimum, roughly here before catch. And these are also different between different rowers, so it's interesting to overlay these. Also, what's very interesting about this graph is the maximum seat speed and where it occurs. You can see whether your leg push is front-loaded or not, and how high you can get. This is very individual. I've seen people being able to push their seats at very high speeds, and unlike myself. And then in these numerical data, you get the average max seat velocity. This was all I wanted to show now, and in the next video I will show you how to compare rowers with each other. Thank you.